Hello, I'm Shreya. I'm here to present my video presentation on the 1 month internship taken by me on the topic embedded system by Emertxe. First, let us see an overview about the internship. It consisted of 4 weeks. The first week was basically introduction about the internship and what all we will study. And the second week was basically C programming. All the basic concepts were covered. And the week 3 was project building, and week 4 was Disha workshop. The main goals of this internship was to clearly understand the concepts of C language and to obtain good quality and style in programming. It also focused on gearing up the programming in embedded environment and the project development. So the basics of C programming that we studied included keywords, that is keywords used in data types like int, float, character, and qualifiers like constant, volatile, and keywords used in loop like for, while, do while. And we studied the typical C code. It starts with documentation, and then comes the pre-process statement, that is the header files and all that we include, and then the global declarations, and then the main code, and the function definitions for all the functions that we have called in the code. Then we studied about number system, binary, decimal, hexadecimal, and octal, and conversion of each number system to the other, like binary to decimal, decimal to hexadecimal, and all the reverse orders. And the other important concepts covered were data representations, like data representations in a bit, in a byte, a word that's a sequence of bits. We also studied about signed and unsigned integers, how to represent it in binary, how to convert in decimal, and we also learned about modifiers, and we also learned how to convert float to decimal values. We then studied about the conditional statements, which included if else, switch, and if else and switch are one-time execution conditional statements, while for, while, and do while are loops. We saw examples for each of the conditional statements and understood in detail what each one does, its function, where we should use what, and so on. And next we studied about operators. First operator we studied was unary operator, then binary operator, and ternary operator. And this is the classification that is based on the operand, the number of operands. If there is only one operand, we call it unary operator. Two operands are called as binary operator, and three operands are called as ternary operator. Ternary operator generally chooses between two results that needs to be given. And based on the operation, we have arithmetic, logical, relational, assignment, bitwise, and language operators. Arithmetic operators include all the arithmetic operations that we need for execution of a program, that is the addition, subtraction, multiplication, division, and the modulus operation. Logical operations include logical and logical or and logical not. Relational operations include greater than or equal to, less than or equal to, and not equal to. So these operations are used in conditional statements like if statements. We check this condition to execute a particular set of the code. And next is the assignment operator, that is equal to, is used to assign a particular value to a particular variable. Next is the bitwise operator, which includes bitwise and, bitwise or, left shift, right shift. We also saw the language operator, which includes size of. This gives the size of the variable that is specified within the bracket. And the other main important concepts covered were arrays, functions, pointers, dynamic allocation, standard input output, strings, preprocessor directive, macro, user-defined data types, and file handling. In arrays, we saw about the syntax used to initialize an array, printing an array, storing an array, and how to copy an entire array. And we also saw the programs based on all these concepts, like simple programs where we initialize an array, print an array, and so on. Next, for functions, we saw the syntax, how to define a function, how to call a function, and how to write a function, the return values, parameters, how to pass different parameters like pass their values, pass their reference, and so on. And we also saw about pointers. We saw what is a pointer, why is it used. It is used to store the address of a variable, and we also learned about pointer arithmetic, how to use pointers when we undergo some arithmetic operations. And we also saw about null pointer. And then we saw about dynamic allocation. That is malloc, calloc, realloc. And under the standard input and output, we had all the header files included for standard input and output. That is hash include stdio.h. And we have also saw the syntax for the input and output statements, like syntax for printf, scanf, and under strings we saw how to initialize a string, what are strings, how they can be used. The array of characters is called as strings, and all the functions that can be done with the strings were also concentrated on. For example, the length of the string can be found using str length, and two strings can be compared using string compare. We can copy an entire string to other string using string copy. And under preprocessor directives, we included all the header files, the header statements that we use, like hash include, hash define, if define, undefined, and so on. Then we saw about macros. Macros are the identifiers that we give in the preprocessor directive for a particular definition. Then we saw in brief about user-defined data types, structure, union, type def, and enum. Then we also saw in brief about file handling. This constituted the first week of the class, which had all the basics of C programming. The next week, we started learning about embedded systems. What is an embedded system was the first topic. We also learned the difference between microprocessor and microcontroller, the different types of memories available in microprocessors or controllers like RAM, ROM, EEPROM, flash. And we also learned about different types of peripherals that we are using. It included the LEDs, switches, CLCDs, timer, buzzer, fan or motor. We have to note that in our particular project, we use the fan in place of motor to represent the washing machine spinning. We also studied the interfacing between each of these LEDs. We saw some programs to blink an LED, toggle an LED. We learned about tactile switches. We saw in detail about pull-up and pull-down circuits. And we saw how to interface each of these peripherals with the PIC simulator. Next, the project that we have done in the third week was mainly about a washing machine, simulating a washing machine using PixSimLab. No hardware components were used, and the aim was to replicate a real-time world washing machine in virtual environment with all the peripherals that are available in the PixSimLab. We also defined all the parameters required for real-time washing machine. So now let's see the project requirements. The first requirement was the power on screen. When the board is reset, we have to press key 5 to power on the washing machine on the CLCD. And we have to wait for the user's command till the user presses switch 5. If switch 5 is pressed, the washing machine turns on and we print powering on washing machine. Here we can see the CLCD display. First, the screen will be visible. Press key 5 to power on washing machine. As soon as the user presses switch 5, we show this powering on washing machine. The next requirement is washing program selection and navigation. Our washing program menu contains several washing options. These washing options can be visible in daily life washing machines that we use in our homes, like daily, heavy, delicates, whites, stain wash, eco cottons, wools, bedsheets, rinse and dry, dry only, wash only, and upholster. We have to wait till switch 4 is pressed. Switch 4 is used to scroll between the options available. And to select a particular option, we'll long press the switch 4 so that the option highlighted with the star is selected. This is the CLCD for washing program screen, and we can see the programs daily, heavy, delicates. To scroll between this, we can press switch 4 and the star visible here. When we long press the switch 4, the program next to this star will be selected. For example, if I press long press switch 4 now, daily will be selected. The next requirement is water level selection and navigation. This is also similar to the program selection. This allows the user to select the water level. Water level also has a menu which has auto, low, medium, high, and max. And we can scroll between the options available using switch 4. And auto, low, and medium will be visible at the same time. Once we press switch 4, it scrolls and we can see low, medium, and high. And similarly, after the last option, we can again view the first option. Like after 4 clicks, we can view high, max, and auto. A long press of switch 4 will select the option highlighted with the star. Same as the case for washing program screen. And this is the CLCD display for water level. You can see the 3 options. If long press, the option near the star will be selected. The next requirement is to start the operation selector. Once the washing program and the water level is selected, option to start the washing machine is provided to the user. If switch 5 is pressed, the machine is started. And we display the function selected and the time taken for the particular function. Like for a particular function and the particular water level, we have assigned certain time limits. So that particular time will be shown on the screen. And this time was taken based on the data sheet available. And after displaying this, we switch to the function screen. If switch 6 is pressed, we go back to the washing program screen. In case we have selected some wrong option and we have to correct it, we go back to the washing program screen by pressing switch 6. And this is the screen, washing program screen. We display switch 5 to start, switch 6 to stop, and the program that we have selected is displayed here, and the time required, minutes and seconds, are displayed here. In real time, this will be hours and minutes, but for simulation purpose, we have given it as minutes and seconds. The next project requirement is function screen. The function screen displays what operation is going on, like wash, rinse, or spin. And we have assigned this for each and every washing program, like how much time takes for wash, rinse, and spin. It displays the output accordingly. And it also displays the time left for the washing program to complete on the CLCD. This is done with the help of the timer present. And if switch 6 is pressed, the washing machine pauses. It waits until switch 5 is pressed, and once switch 5 is pressed, it resumes the operation. And as I said earlier, the washing machine here is represented by a fan. Switching on of fan represents switching on of the washing machine. And switch 1 represents door status. Once the door is open, that is, once the switch 1 is pressed, a buzzer sound can be heard, and we display door open, please close. This is the function screen. We display the current function that's going on and the time left for the program to complete, and 5 to start and 6 to pause. Once 6 is pressed, the program stops and it waits for switch 5 to be pressed. Once 5 is pressed, it again resumes. And switch 1 represents the door status. If switch 1 is pressed, the right side screen will be shown. Door is open, please close. And the next requirement is completion status. After the timer stops, that is minutes and seconds become 0 and 0, it displays program completed, remove clothes on CLCD. And it goes back to the washing program screen. Program completed, remove clothes. This will be the output displayed once the program is completed. Next, let's see the block diagram. That is the design of the washing machine. First, we have a microcontroller, which is the PIC microcontroller that we use. And for powering on, we use switch 5, as we saw earlier, and switch 6 for pause or stop. Navigation and selection is done using switch 4, and the door status is represented by switch 1. All these switches are present in the board in the PIC simulator. And we have a CLCD display. We also have a buzzer and a motor. Buzzer represents the opening of the doors, and the motor represents the washing machine working. The tools used in this are PICsim Lab Simulator. The board used is PIC Genius board, and the microcontroller used is PIC 16F8778. And we also used MPLab XIDE, and we also used XC8 compiler of MPLab. To conclude the washing machine simulation using PICsim Lab was a very effective tool for learning and applying all the concepts that we learned in embedded system. We got a hands-on experience that complemented the theoretical knowledge that was provided. We found a perfect application of embedded C and all the theoretical knowledge that we gained. This was our foundation in the field of automation and control systems. So next we can see our project demo. So this is the PICsim Lab, and we have the clock frequency set to 20 MHz. The board used is PIC Genus PICGNAOS, and the microcontroller used is PIC 16F8778. You can see the peripherals attached to the board here. First one is CLCD. This is used to display all the necessary instructions and what is happening in the washing machine to the user. We also have a fan. The fan represents the washing machine switching on and off. If the fan is on, the washing machine is working, and if the fan is off, the washing machine is not working. It's in idle state. And we have a buzzer. The buzzer indicates the opening and closing of the door. If the door is open in the mid of the washing machine operation, the buzzer buzzes off, and it goes off when the switch is left. Switch 1 is used for door opening and closing representation in this board. Buzzer also goes on when the washing program is completed and we have to remove the clothes. So to indicate that, buzzer again goes off. We also have some switches here, tactile switches. We can see RB0, which indicates switch 1, RB1 is switch 2, RB2 is switch 3, RB3 is switch 4, RB4 is switch 5, and RB5 is switch 6. So I'm reloading the hex file. So we can see press key 5 to power on the washing machine. This is the powering on screen, first screen. So I'm pressing switch 5, that is RB4. We can see powering on washing machine. So the next is the washing program screen. To navigate within the washing programs, we can use switch 4. First we can see daily, heavy, delicates, whites, stain wash, eco cottons, woolens, bed sheets, rinse and dry, dry only, wash only, aqua store. And we can again see it's repeating from the first daily, heavy and so on. So once I long press the switch 4, the option corresponding to the star is selected. So daily is selected now. And it moves on to the water level screen. Similar to the washing program screen, water level screen also has a list in the menu. So first is auto, low, medium, high and max. And we can see again auto is coming back. And we are using switch 4 for navigating, and long pressing switch 4 selects the option near the star. So now low is selected. So it displays press switch 5 for starting and switch 6 for stopping. Here stopping goes back to the washing program screen, and we are pressing switch 5 for starting. So we display the program and the time. And we can see the fan is started, and switch 5 is for start and switch 6 is for pause. So I'm pressing switch 6. We can see the fan is stopped and all the functions are stopped and the timer has also stopped. And we have to note that the function here will be wash, rinse and spin. Each time period, wash time period, rinse time period and spin time period is specified for different washing program and washing levels. And the time required for each washing program and water level is also specified. And the timer is working on the basis of this information provided by us from the datasheet during the coding part. So I press switch 6 and thus the fan stopped. So I'm again pressing switch 5. This starts the operation again. And RB0 represents the door status. Once I press the door, it showed door open, please close. And the buzzer also went off. Once I left the switch, the operation resumed. We can see the function came to rinse and then spin. Now the program is completed, so it displayed program completed and remove clothes, and it went back to the washing program screen, starting the process all over again. So this is the basic demo of the project that we have done in this 1 month internship. Thank you so much.